In question number 8, we're asked to express as a single log, but we have log base 8 and log base 4. We need to change the base. So that's the first thing I'm going to do. I'm going to just change the base. I could put the exponent of 2 back into the log, but we don't really need to be quite honest. We can just keep that out there, and we can change the base without doing that. Now, since we have base 8 and base 4, the common base is base 2. So I'm going to change this to a base 2 log. And then I get log base 2 of 8 in the denominator. That can be evaluated. Plus, I'm going to have log base 2 of x to the power 8, y to the power 2 over log base 2 of 4. Now, there is a property where I could actually I could have square rooted the base and the arguments, and that would have, as long as I did it the same, then that would have given us given us the equivalent log expression with base 2. But in this case, it's just easy enough to change the base, and I can evaluate the denominator logs because they are base 2 numbers. So I end up with 2, in this case, 2 log base 2 of 64. In fact, I'm going to actually put that in because this is going to be easier to combine without that 2 in front. So I'm going to end up with 2 to the power 6 to the power 2, which becomes 2 to the power 12. So 64 is 2 to the power 6. I brought that power 2 in. This becomes x to the power 12, y to the power 12. I'm just bringing this power into here, here, and here. Okay, and then in the denominator, this just becomes 3. Plus, this is going to be log base 2 of x 8 y squared all over 2. Now that is a cube root. That's divide by 3 in a log, so that means it's a cube root. That's divide by 2, so it's a square root. So then I can apply that, and maybe I'll just show it like this. Put it as 1/3 first, and that power can then apply into the log. And since those powers inside the log are all multiples of 3, they are evenly divisible. The same thing here, base 2, x to the power 8, y squared. Okay, so then this becomes log base 2, 2 to the power 4, x to the power 4, y to the power 4, plus log base 2, x4, y to the power 1. Now, since we have plus, logs can be combined with plus, which means we multiply the inside or arguments together. So this becomes log base 2, 2 to the power 4, x to the power 8, y to the power 5. Okay, now I can leave it like that. However, any base 2 log and base 2 exponent, we really should evaluate that because this is really equal to 4. And then we have log base 2 of x to the power 8, y to the power 5. So I split off that base 2 to the power 4. I split that off using log properties. And I can, if I do that, I'm going to have to show it as a plus. Okay, so this becomes, in the end, 4 plus log base 2, x to the power 8, y to the power 5. Okay, so this is good enough. This is better.